This is our first lecture. It is called Our Planetary Neighborhood. This lecture is going to give you an introduction as to what can be found in the solar system. And just like I mentioned in the introductory videos, these lectures will always begin with the learning outcomes that you should be able to do by the end of this lecture. And so at the end of this individual lecture, you should have 3 outcomes. Overall, though, what we're focusing on this unit is to accurately visualize the scale or the size and the structure, what it's made out of, what the solar system is, and explain its formation. And to do this, you'll need to do 3 different outcomes, 3 different essential concepts. That would be to identify the different objects that are in the solar system. Then you'll need to know how to measure distance within the solar system. And then you'll also need to observe different patterns or trends in the solar system. And so we're going to cover each of these in detail through this lecture. And so when we talk about what is in the solar system, I like to start off with a little Rick and Morty quote. There is literally everything in space. Everything is in space. This is a quote, Rick and Morty. I'm a fan of the show. I don't know if many of you are. This is a episode. I always remind you, like, start off with that on this lecture. Everything is in space. So what are the different objects that can be found in our solar system? Well, there are 4 different types of objects, general categories, many of which you're probably familiar with and some that you might not be familiar with. First up, we have the planets. Those are the 8 planets that we're all familiar with: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And then next to these planets are the asteroids. And so here we have the main belt of asteroids out here. And then comets occasionally pass through our inner solar system, and you may have seen a comet in your lifetime. Those originate out farther in our solar system, and they have large clouds around them. And so we see those here. And then out here, it looks like there's another asteroid belt, but actually these are the Kuiper Belt objects, and we will talk more about those you may not be as familiar with. So starting off with our planets, we have 8 planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. It may be helpful to think of a mnemonic tool for memorizing these. My very educated mother just served us noodles. That can help you remember all the different letters and in their order. Usually I find that people know this by now. It's not too difficult. This image, though, does highlight the different sizes for the various objects in our solar system. Here is our sun, and then here are the relative sizes for the inner terrestrial planets as well as the outer gas giants. However, what that last image did not show you were the relative planetary distances. This image has been reproduced to show the relative distances in our solar system. All of the objects, though, are the same size, which is not true. However, you can get an idea of just how far the objects are apart from each other in this image. The way that we measure distance in the solar system is a term called the astronomical unit. The astronomical unit corresponds to the distance between the sun and the Earth. This distance, which is about 93 million miles, corresponds to 1 astronomical unit, or 1 AU. And as you can see here, as we move further out into the solar system, things start to get further and further apart. The distance between the sun and Neptune is actually 30 AU, 30 astronomical units, which corresponds to about 2.8 billion miles. So it's really far distance. It takes a really long time for things to travel out into the outer solar system. And as you see, all of these planets are spinning around. Every time the Earth goes around the sun, that is 1 year. And as you can see, it takes much longer for the planets further out to pass. So this has been reproduced to scale by a former colleague of mine. Now, what about these orbits? Well, all of these orbits are actually orbiting the sun And they are not actually circular. They're almost circular. They're ellipses. They are very close to being circles, but they are not true circles, indeed. And another key aspect is they're all orbiting in a counterclockwise fashion. If you were to look down on the solar system, you would see them moving to the left and to the right, and then going around in a counterclockwise fashion. The sense of rotation, or if you were to sit in your chair and sort of spin around once, is also in the counterclockwise direction for most planets. All of the planets except for Venus and Uranus orbit in a counterclockwise direction. They rotate in the same direction as they are orbiting, all except for those planets. And we might talk about why that is. Pluto is a Kuiper Belt object, and it also orbits in a similar direction. So with this, we can then start to think about two different types of planets. We just covered the 8 planets, but we didn't really talk more about how they are different from one another. With this, we can talk about the terrestrial planets. These are planets in the inner solar system. So that's the 4 planets: Earth, Mercury, Venus, and Mars. And oftentimes the moon gets associated with these planets as well. And then we have the Jovian planets, Jovian meaning Jupiter-like. And so we have Jupiter, Saturn, Uranus, and Neptune. So as you can see, there's some key differences between these. The great red spot here on Jupiter, it shows us just how large it is. The relative size of the planets is very small compared to just this massive storm on Jupiter. So these planets are much larger further out in the outer solar system. Talk more in detail about these various planets. So for the terrestrial planets, terrestrial comes from the root word terra, meaning earth-like or soil. All the 4 inner planets have surfaces. These surfaces are rocky surfaces. They're hard. You could walk on them. And so we're also including the moon in here. These planets, though, are relatively small in size, but have a large mass, meaning that they are relatively dense. These planets are dense. They're made of rocky material. This is going to differ for what we see in the outer solar system. Many of them have somewhat of an atmosphere, and we can see that for the Earth here. We can see the atmosphere, and also Venus has a very thick atmosphere that covers its surface. And this image here is from radar, is actually able to see through to the surface of Venus. Here's a look at the insides of the terrestrial planets. From this, you can see that all the terrestrial planets are differentiated. This basically means that they have been separated into layers of surface crust, mantles, rocky mantles, and iron-rich cores. So we see that true for Mercury, Venus, Earth, the Moon, and Mars. And we see the different layers labeled here. So these have distinct layers of different compositions for each of these planets. Moving on to the Jovian planets, we can see that they are very different from the terrestrial planets. Rather than being high density, these are actually very low in their density. However, they are much more massive than the Earth. So think of something that is really big and inflated, something like a basketball, versus something that is maybe like a rock or a billiard ball or a pool table ball. So it's low density, meaning that it is much larger for its relative mass than the Earth. And most of these outer planets are composed of gas. These planets have no solid surfaces. If you were to fall into Jupiter or Saturn, you would fall through gas until you would reach some point at which you would enter into a slurry or a mixture of liquid hydrogen or liquid methane or some other gas that has been condensed, and eventually you would get to the core, but there's no concrete surface that you can really walk on for any of these objects. All of these planets have have ring systems, not just Saturn. Actually, all of the planets have been identified to have rings orbiting around them. And they are also, I should say, they also have many moons. All of these planets have numerous moons, dozens or I think maybe Saturn and Jupiter are up to close to 100 different moons of various sizes in orbit around them. So now that we've covered the planets or the big objects in our solar system, let's talk more about the smaller objects that are present. First, we'll talk about the asteroids, and then we'll talk about the Kuiper Belt objects. The asteroids, these objects are made of rocks and minerals. I think of them as having like a potato-like shape. They are made of rocks and minerals, so they're relatively hard surfaces that are objects that are composed of these different materials, and they all come in all kinds of shapes and sizes. And so you can see here that they can be really large, on the order of several or dozens or hundreds of kilometers wide, to being relatively small, less than 1 kilometer wide. We've sent spacecraft to see these various objects, and we can see that they have also experienced impact craters just like the planets. Here's a picture of the asteroid Bennu. We have sent a spacecraft to Bennu. It has gathered samples and it is on its way back. This was an image that was taken during its closest approach to Bennu. And as you can see that this asteroid doesn't look relatively solid. It's actually a rubble pile made up of many, many smaller pieces that through their gravity have combined and coalesced together into one larger object. This is relatively interesting because if this object were on a collision course for Earth, how would we address that? We can't blow it up because then it would just become many, many small pieces. And so NASA and the US government are very interested in studying more objects like this so that we can identify ways in which we can avoid colliding with a large object such as this. Here is an asteroid in motion. These objects are not static. They are actually rotating and tumbling through space as they orbit the sun. Here's a radar image showing a time-lapse image of this asteroid turning about its axis. So where are the various asteroids in our solar system? Well, there are 3 different types of asteroids, and they have 3 different locations. We first have the main belt of asteroids, and this is the largest group of asteroids in our solar system, and they are existing in between the orbits of Mars and Jupiter. And so these objects here are labeled in green, and you can see there's a large cloud of them just outside the orbit of Mars. Here is us, Earth, and there's Venus and Mercury and the Sun. The second group is a group of asteroids called the Trojan asteroids. And these asteroids are not in the main belt. In fact, they are actually part of the orbit of Jupiter. Jupiter's gravity is so strong that it creates a balancing force between it and the sun that occur at these different points in front of and behind the orbit of Jupiter. These are called Lagrange points, and they are specifically gravitational sinks that are created by the balancing of forces between the gravity of Jupiter and the sun. And so these asteroids never enter the inner solar system, and they just stay in front of and behind Jupiter as it goes around the sun. And then finally, in red, we have the near-Earth asteroids. These are called near-Earth asteroids because they travel through the inner solar system. Any asteroid that makes its path through one of the part of the orbit of the Earth and through the inner solar system around the sun is termed a near-Earth asteroid, meaning that it has potential to come near to Earth and potentially impact. And we'll talk more about these later on. So here's some visualizations of the different asteroids in their orbit. We can see the main belt of asteroids here in gray. And then this graphic, as it rotates, it will show us the locations of the Trojan asteroids. And this actually follows the path of the Lucy mission, which is a new spacecraft headed to visit these Trojan asteroids. This graphic shows us the near-Earth asteroids. And so here we are in the Sun, Mercury, Venus, Earth, and Mars, and we see all of the asteroids that are passing through and near to the Earth. We can see them labeled in red. There's quite a lot of them. And two asteroids that come particularly close to Earth, their paths are labeled in white. This is Bennu and Ryugu. And we can see that the near-Earth asteroids are moving in quickly throughout the inner solar system. Okay, so then moving into the outer solar system, we'll focus on comets and the Kuiper Belt objects. So here's another graphic that shows us the pathways for various comets. They are labeled in white, and we can see that in the solar system, where the sun, this is Jupiter. Here are all the asteroids in the inner solar system, and then the various outer planets. We can see that the asteroids are making their way from really far out into the solar system and then back into the solar system. These are traveling on very wide, very elliptical pathways. They're not circular. They come into the solar system and then they go out into the outer solar system. Out here are all the Kuiper Belt objects, these yellow ones, and so you can see them orbiting out past Neptune. And then here again are the paths of some of the longest comets that we know of. So what are these Kuiper Belt objects? These Kuiper Belt objects, these are icy objects that are in orbit around the sun out past Neptune. Pluto is one of these Kuiper Belt objects, but we have many objects like Pluto, like Aries. Here it's labeled here. And we have some ideas of the various sizes for these objects. We've taken pictures of Pluto. Here's Pluto and its largest moon, Charon. And then we have artistic representations of the various moons that exist in the outer solar system. Sorry, the various Kuiper Belt objects, not moons. Sometimes these will be called KBOs as well. And just for reference, here's the size of Earth's moon. And as you can see, Pluto is actually smaller than Earth's moon. Okay, then wrapping up with these objects, we have the comets. The comets are in orbit around the sun. They come from really far out distances in space, out past the Kuiper Belt. These objects are not made of rocks and minerals, but in fact, they are made of mixtures of dust and ice. And so when those objects come close to the sun, that ice begins to heat up and sublimate and be transformed into a gas. And this is why comets have such a bright glow to them, is that their gas is giving off, it's evaporating the ices that it contains, and it's kicking off dust, and that dust is reflecting the sunlight. So they appear very bright because they are reflecting a lot of light back towards us. Here are some images. This is a comet Hale-Bopp, and then here's another comet in 1996. It's important to realize that these comets, they take very wide paths. They come into the sun, they come close to the sun, and then they head outwards. But as you will see, their tails do not follow their path. Their tails, in fact, are always pointing away from the sun. This is because the sun's light and the sun's radiation is always pushing outwards, and this causes that dust and gas to be pushed outwards as well. And so no matter where the comet is in its path, the tail for the comet will always be pointing away from the sun. So regardless if it is coming in or going out, the tail will always be pointing away from the sun. Here's some closer images that we have been able to gather of comets that we have visited with our spacecraft. This is the comet 676P Churyumov-Gerasimenko. And this is a very large comet that came through our solar system. As you can see, this is the size of a Boeing 747, and this comet is much larger than that object. And as you can see, as this comet got closer to the sun, that ice that was trapped within it began to sublimate and release its gas, kicking up dust and gas into the surrounding environment, and taking the form of these jets or these geysers that then erupted, releasing that gas and shooting that dust out into space. Here's what it looks like on the surface of that comet. This was a time-lapse video that was taken by a probe that we sent down to the surface of the comet. Remember that the gas is sublimating, and so it is kicking up all kinds of dust that is then reflecting the sunlight back towards the camera. It almost looks like a beautiful a snowy blizzard on the surface of this comet. I think it's really amazing that we have these images of objects that are moving at such high speeds through our solar system, and yet it looks almost peaceful. Okay, so what are some of the properties and trends that we can observe in the solar system? Well, a first trend or trend or change that we can see through with distance is that in the inner solar system, we have planets that are made of rocky material. But when we move to the outer solar system, we have planets that are made of gas and ice. So ultimately, what we're seeing here is a change in the composition or a trend in composition or what the materials are made out of. With this, we see a change in the density. There's a trend in the density that moves from planets that are very highly dense in the inner solar system. So we see relatively high densities, lots of mass for not a lot of space, to planets that are relatively low in their density, very large planets in terms of their diameter and mass, but their ratio, that taking the mass and dividing it by the volume, results in a very relatively low number. And this is because those planets are made up of a lot of gas and it takes up a lot of space. And so ultimately we see two trends. There's that trend in composition or what the materials are made out of. And then we see the trend in density where we're moving from really high density planets to relatively low density planets. And so just sort of visualizing the difference between these, we have sort of a bowling ball versus a basketball. The bowling ball is going to be much more dense. There's a lot more mass contained within that space. And then we have a basketball where it's mostly filled with gas. It's relatively large. Ultimately, this is not a great comparison because the terrestrial planets are not the same size as the Jovian planets. This should more be like a pool table ball. It's relatively small, but really dense. And then here is a graphic that sort of compares this. In the inner solar system, we see relatively high densities, and then we have be able to compare the various materials. Here we have the density of metal. It's really dense. Here's the density of rock. And because the terrestrial planets are a mixture, not a mixture, but they have the different layers of metal and rock, we see their densities sort of fall in between those different densities. Moving out into the outer solar system, though, we see that there's densities that are even less than that of water because we're dealing with gas. They do have rocky cores, possibly iron cores, but that ultimately does not contribute as much mass as would be needed to have a density like that in the outer solar system.